Hello folks, and welcome to this lesson on separation techniques. By the end of this lesson, you should be able to explain how differences in intermolecular forces of molecules can be used to separate mixtures of compounds, and explain how solvation, filtration, recrystallization, evaporation, distillation, and chromatography can be used to separate mixtures. So in this lesson, we're going to be talking about a few different separation techniques. And when I talk about these separation techniques, I mean that there is a mixture of several different compounds and chemicals, and you're trying to separate them from each other. Now, in these techniques that we're going to be looking at today, we are going to be separating them without reacting any of these chemicals. So none of these chemicals are going to become something else. We're only using physical changes and so on and so forth to be able to make these separations. Now, as a result of this, all of these techniques are going to take advantage of what types of intermolecular forces these chemicals are capable of making, and also which one fits in which situation is also going to depend on the mixtures themselves. So again, the four separation techniques that we're going to be looking at are distillation, solvation, filtration, and evaporation. All three of those processes are part of one technique. Recrystallization and chromatography. Alright, for distillation, we are going to be looking at two liquids and or solutions that are dissolved within each other. Now, these solutions are typically going to be miscible, which means that it doesn't matter what proportion you have each of those liquids in, they'll always dissolve together. And so because they're liquid and because they're mixed in completely, it's not going to be easy to use something like filter paper to separate these two. So instead, what happens is that you use the boiling points of these liquids. So you're going to take this mixture and you're going to put it into this round bottom flask, which you are going to heat up. I suspect that it's a round bottom flask specifically, just because the heating will end up being more even, though I'm not sure how important or how vital it is that it is a round bottoms flask specifically. You're also going to have a thermometer, which is going to help you keep track of what's going on and when things are happening as well. The top of the flask is going to be sealed up, so anything that is going to leave this flask is going to be leaving through this particular tube, and you're going to want a beaker at the end to collect everything that comes out of it. So, once you put your mixture inside the distiller and you heat it up, it's going to keep on going until something boils. And the thing about the different substances that we have is that they all boil at different temperatures. So even if you have a mixture of stuff, one of them is always going to boil first, and then the other one will boil after that. So one of them is going to boil. It's going to, the steam or the vapor from that is going to go up, and then because there's nowhere else for it to go, it's going to go through the tube. Now, this condenser is going to take that gas, and since you're using cold water and you're going to have it flow around this tube, it's going to cool down that gas, that boiling the gas from the boiling, and it's going to go from gas to liquid again, which is what you are collecting in this last beaker. The thermometer is going to help you know at what temperature you're having all of this happen, so you can figure out and make sure that you are actually distilling the liquid that you were planning on distilling. Because this whole process takes advantage of those melting points, what ends up being in this beaker is going to be purely that liquid that boils off first. Out of all of the processes that we're going to talk about, this is probably the one that you might hear about most in real life, because this is used in big industries to purify the certain chemicals that they want. The next process that we're going to talk about, or next technique that we're going to talk about, is going to be solvation, filtration, and evaporation. So in this particular case, we are going to be dealing with a bunch of solids that have been mixed together, And what happens here is that you take advantage of the different solubility of the different substances that are mixed together. So in this particular case, you need to make sure that not both of them or all of them do not dissolve in the same type of solution. So this is one where if you have something that has high solubility and one that has low solubility, this is where you can take advantage of that. So you're going to toss your mixture into a beaker or whatever vessel, and then you're going to add a solvent into it. It can be water, it can be something else. You just have to make sure that it matches up and it does dissolve one, but not the other. So after it's dissolved, one of those chemicals will completely be in the solution. The other one is going to stay as a solid apart from the solution itself. So this is the solvation part of it. The filtration part is you then take this and then you put it through some kind of filtering process, whether it's filter paper or something else. When you do that, the solid bits are going to stay in the filter paper, and then you can take that, dry it out, and then you have that particular chemical ready to go. And then out of the solution, well, the rest of the solution is going to be collected later. So filtration. Now, you might want that original chemical that was dissolved in your solvent, in which case you boil off or evaporate off your solvent. So you can boil it, you add heat, or you can just leave it out for a long time if it's something that's going to evaporate pretty quickly, and whatever's left over is going to be that other chemical, that other solid. For recrystallization, we are dealing with solids again. But the thing about this one is that both of your solids are going to always dissolve in the same type of solvent. Now, just because they both dissolve in the same solvent doesn't mean you can take the solid chemicals, that mixture, and actually mechanically take it apart. What you still do is you're still going to toss them into a solvent, and then you're going to heat it up. So you do want to make sure you're heating it up so that everything is dissolved. So you're not going to have anything solid remaining once you heat it up. After that, you're going to cool it down very, very slowly. And the thing is that if you have different chemicals, they are going to have different solubilities in whatever solvent you have. So one is going to be more soluble than the other one. Now, the one that's less soluble is going to start crystallizing at a higher temperature than the other one. So once again, if you have two solids and one of them is less soluble, it needed that really high temperature to all completely dissolve. So that means that if the temperature drops even a little bit, it's not going to stay dissolved, which is why it's going to crystallize out. And so you want to make sure that it's still at a temperature where the other substance is still dissolved in your solvent, but the other stuff, the other chemical, will completely crystallize out. Then you're going to filter it, and if what you need is actually in here, then you're going to do the whole evaporation thing. The last technique we're going to be talking about is chromatography, and this is something that you can perform using different substances. So one example is paper. You can take chromatography paper and use it for this particular technique. So for chromatography, your substance is going to be in solution, and so what you do is you take that solution with all of your substances, and you're going to make as concentrated of a dot at the bottom of your piece of paper. You are also going to mark where that line is, where you've put that sample on, using something like a pencil. After that, you're going to take this paper, put it into a tube or some kind of vessel where the sides of the paper are not going to be touching the walls of the big container. And you're also going to have a bit of solvent, and this has to be one that will dissolve at least some of the compounds that you're looking at, but you're going to have it in solvent. The solvent should not reach that pencil line. It'll be somewhere below it, and your paper generally isn't going to be touching the bottom of the container either. Due to adhesion, the solvent is going to attach itself through intermolecular forces and start climbing up that chromatography paper. And the thing is that as the solvent underneath here passes that point that has your mixture of compounds, due to intermolecular forces between the compounds and the solvent, if it is able to dissolve, your compounds are going to start also climbing up with that solvent. So as time goes by, you're going to see that changes are going to happen as your solvent keeps on climbing. So the solvent is always going to be moving a little bit faster than the compounds themselves, and so that line, which shows how far that solvent has climbed, is referred to as the solvent front. Your compounds, depending on what they are going to climb different amounts. Now, factors that are going to help these compounds climb is 1, the solubility in the solvent. The more soluble this compound is in your solvent, the higher it's going to be able to travel, because the forces between that compound and the solvent are going to be stronger. And so because it's stronger, it's going to be pulled up farther. Another factor that can affect this is size of the compound itself. If you have something that is very big, very heavy, it's not going to travel as far because it would take a lot of energy to move it further up. So at some point, that is before when the solvent front hits the edge of the paper, you're going to take it out and you're going to have everything stop and dry. So once you take it out, there's no more solvent coming down from the bottom. So it is going to stop. But at the time that you stop, you do still want to mark your solvent front, and then you'll have your compound spots to be able to tell how far those compounds have traveled. Then you're going to calculate something called the RF, which is the retention factor. Your retention factor is going to be the distance of your solvent under your distance of your compound of interest. So, for example, your RF, your retention factor for compound A, is going to be, that is 8 centimeters over 10 centimeters, so that's going to be 0.8. So it doesn't matter how long you leave this or what type of paper you're using or so on and so forth. For the specific compound and the specific solvent, these retention factors are always going to be the same. So once you figure out what the retention factor is, you go and search for what retention factors are for the solvent and in this compound, and you can match it up and match out and figure out which compound you're looking at. Another type of chromatography that you can do is thin layer chromatography, and the general gist of it is going to be the same as paper chromatography. You're going to have this substance that everything is going to happen on. You're going to trace out your beginning line. You're going to have little dots of your mixed sample in there. You're going to put it in solvent. That solvent is going to be below where the dot is. The edges shouldn't touch the edges of the container. It's going to go up so far, etc. and so forth. All of that stays the same. The only difference is what you're doing the chromatography on. So for thin layer chromatography, you start out with some kind of base material. So this can be glass, or it can be metal, or it can be plastic. After that, you add a thin layer of something like silicon dioxide or aluminum oxide. And then you put the sample on here, and then everything happens. There are some advantages to thin layer chromatography over paper chromatography, one being that because it's not paper, once you have the chromatography, once you put the sample in solvent and let it go to where you want it to go, it's going to dry off a lot faster than paper does. Thin layer chromatography is also a lot more sensitive, and you can also use smaller samples than you have to with paper chromatography. That's the end of this lesson. I'll see you next time.